Okay, so looking at number 8 for Wednesday. My first thought would be arctan, but there's a square root, so no arctan. Second thought would be trig sub if. Trig sub's always a last resort if u sub doesn't work. Because with u sub, I could go ahead and cancel out the x, so it's no longer a problem. I'm going to have 1/2 the integral of 1 over square root of u du. I don't need trig sub, kiddo. Divided by 1/2 would cancel that guy out. I shouldn't put bounds in yet, though, until I get back to the original. Just because it's multiple choice, I'm not worried about my work. So we can go ahead and do the square root of 34? 34 minus the square root of 9. Hold on, something's weird. Oh, 16 and 9 is 25. Square root of 25 minus the square root of 9. So 5 minus 3 is 2. Okay. Yeah, try u sub first. Sometimes it works. I mean, sometimes it doesn't. But right.
3 on this.
Yeah.
Yeah.
Consider the series where they tell me a ratio of the n plus first over the n. Base of 1 is equal to 16. If this is always true, the ratio is always constant, it's a geoseries. A very hidden geoseries, but a geoseries. And the reason I can see that is because there's a common ratio for every sequence of terms. So I can say, see it?
Yeah.
So to get to the next one, I'm going to cut it in half, and then cut it in half, and then cut it in half. So at that point, I can go ahead and say, since r is less than 1.
Okay.
What else do we have? Anything else on Wednesday? Yeah.
87 and 91.
87 and 91. Okay, so calculator ones. I have my calculator out. 87 is asking for the minimum value of a definite integral, but with a variable. Okay, well, a min makes me think relative min. Relative min makes me think of critical numbers, yeah? And endpoints. So I have my 0, I have my 2, which I could plug in 0 to b. Just because we are allowed to use our calculator, thank goodness, because this is not an integral that we could solve with that chain. No, that's not even integration by parts, that would be times. So 0 and 2, 0 to 0, 0. 0 to 2, I would plug into my calculator and get a value for. But I need to make sure there are no critical numbers. So critical numbers, I need to take the derivative. I guess technically, to be all nice and proper, since x's are inside, I'll do d dt from 0 to b of cosine of ex dx. B is a variable expression, so then FTC part 2, right? Since I have a to u, I can go ahead and plug that in, so I have cosine of e to the b times b prime. Which, if b prime was 0, the whole thing's 0, there's not even critical numbers. So we can kind of ignore b prime, because I don't want him to be 0 anyway, because that means b is a constant. But I need to somehow set this derivative equal to 0, which will only occur when, if I ignore, like factoring, if I ignore the b prime option, since b is not constant, he's variable. Then I have to go ahead and undo cosine. But the nice thing is, wait, we have a calculator. Like, we don't have to stress about this. We don't even have to do, like, trig or anything like that. I can literally just go to my calc and say, okay, so when does, ooh, let me get out of parametric mode, yikes. Let me get into Zoom Standard, and let me get my function of cosine of e to the b and say, when are you 0? Oh, wait, not just when are you 0, but when are you 0 between 0 and 2? I can narrow my search. Are you 0? Oh, I see 1. Oh, I see 2. Oh, struggle. So I have 2 critical numbers in between 0 to 2. So I'm going to need to go find both of those critical numbers. Good so far? I'm going to do like 0.1 just because I'm lazy and it'll put me somewhere over here. That's 1, so maybe like 0.9. Yep, gets me on both sides of that 0. So that's 0.451. I'm going to quit and stow him so I don't have to memorize him. I'm going to go back to my graph and go find me the other 0, which looks to be like 1.2 is on one side, and then like 1.8 would be on the other side. So 1.55. So I'm going to stow that as B. And then all I need to do is compare that to, well, I had 0 as 1. Are both of them though? Oh, see, they're both answers, so I just need to test them. So I'm going to test all my integrals. So I'm going to go from, let's see, there we go. From 0 to A of my, I have the derivative in there. I need the original function. Oh no, he is the same thing. Just kidding. So let's just do, there we go, dx. And then I'm going to do the exact same thing, but instead of going to A, I'm going to go to B. And then instead of going from A or B, oh, that guy's lower, I'm going to go to the endpoint, which is 2. I'm asking myself for the min. Yeah, I find the min to be that second critical point, which would be the 1.55. I guess the other way of doing it, though, technically, is if I was looking at the derivative. Silly me. What can I do with graphs of derivatives? Can't I think about relative extrema just looking at him? If I'm looking for a relative min, wouldn't this guy go from positive to negative? So wouldn't this technically be in my sign chart? My A, and this is my B, negative to positive. My A would have been a relative max. My B would be a relative min. And then my endpoints, well, forget them, they're not relative extrema. I mean, they compare for absolute extrema. But Naomi, I took a second just to kind of recalibrate what I was saying, because this doesn't just say the min. It says a min. So I should have just focused on my critical numbers, trying to find a relative min. But yeah, the answer would be
can you do 88 also?
And then Naomi, remind me of the 91 too. But there might be some others in between, so guys, keep calling them out if you have any around here. Okay, AP guys love to be really tricky on this one.
I'm kind of confused, like, what's even asking.
This one is my F, true? And I know I need to come from below or above, and I need them to agree, which is where they like to trick us, especially when they go changing a function by doing some sort of transformation, which is what's going on in here. Because in some ways it's like, oh, you should just be able to plug in, and plugging in 1 minus 0 is 1, and f of 1 is equal to 2.
Yeah. I put that. That's wrong.
But limits don't exist necessarily at values number 1, and unless the two sides agree. So the two sides agree, the limit will exist, and even if the limit exists, it might not be at the point. So what we have to think about is the following. When we plug into here from below, wouldn't we be thinking about, okay, 0 from below, if we're thinking about domain, value is a little bit less than 0. 1 minus value is a little bit less than 0, like, I don't know, negative 0.1. If I'm doing 1 minus negative 0.1 squared, which would be 1 minus a positive, that's going to be from 1 below. Does it make sense how we could figure that out?
Like a little bit less than 1.
Yeah. And then, if I'm coming this one, okay, 0.1 above, 0.1 squared, wait, it's still positive, and 1 minus 0.1 squared is still a little bit below. So I'm not just coming towards 1, 0 plugged in is f of 1, not just coming towards 1, but I'm coming towards 1 from one direction only. If I was coming towards 1 from both directions, the limit would not exist. But I'm not, because no matter how I plug into this, this value is a little bit less than 1, this value is a little bit less than 1, so actually, A, the limit does exist, and B, the limit is not the at, the limit is where I'm approaching from below, which would be. Does that make sense? Yeah. Remember, our plugging in and solving is only for nicely behaved functions. Every now and then, I'll do nicely behaved too. Anything else before 92?
91.
91. Anything before 91? 90.
I think, I know it's related, right? So, like, I did dp dt of 1/3 pi r squared h, and then I got 1/3 pi 2r dr dt.
Is that all you got?
Yeah. Is it? And then I had dh dt, but I put it like, oh. Okay.
Now, what could have saved you from that? Because you would have had to do a product rule if you started going in that route. Remember, put the pi up.
Yeah.
The other way is, this is right now v in terms of r and h. If you were looking through your clues, is constant rate.
dt is constant, right?
This is dv dt, right? Is 2. What is the rate at which the water level is rising? They want dh dt. Do they give me anything about dr dt? They don't care about r. Now, you could have a dr dt, and there is a relationship between r and h when you're thinking of your geometry. But even though there is a relationship, there's an r and there's the h. If we could use that relationship to get v in terms of h alone, you wouldn't even have to think about a product rule. Good. Oh my gosh.
So you can just ignore it for that?
Well, but properly ignore it, right? So if the h is equal to 12 of my container, it should be upside down, shouldn't it? Anyway, whatever. And then the radius is 3. Then wherever the water is, upside down, is going to have, pretend there's no gravity. Anyway, wherever the water is that's upside down fits the same similar shape as, so I can say that h is 4 times r all the time. So you have options. Either you get r is equal to h over 4, plug in right now, and forget about r altogether, not have to worry about him again. Or you go the other direction and you say, hey, dh dt is equal to 4 dr dt, and use this once you have that nasty product rule with dh dt's and dt's.
Kind of like that one.
Okay.
Yeah.
The product rule thing?
Yeah.
Because that way you just go for it, right?
Yeah.
So if you go for it, it should have been
2r dr dt.
Yeah, and I would have just pulled out the 1/3 pi, not to worry about it. You can do whatever you want with them. The second d first would be 2r dr dt times h plus first d second would be r squared dh dt, right? So then you just say, okay, what do I need? And as soon as you saw this, you're like, okay, it's okay for him to be unknown, but everything else needs to fill in. So we have the 2 to throw in there. We have the 1/3 pi there. We have our, when the depth of the water is, here's our such that h equals 5. So that's going to be 5. If h is 5,
Is r 3?
r is only 3 for the container, but not for when h is 5.
Okay.
Does that make sense?
So would we just do it all in terms of h and use h over 4?
Yeah.
Okay.
But you can still do that at this point too, because but you'd have to consider this at some point. And say, okay, well, if h is 12 when r is 3, then if h is 5, then r must be 5/4. dr RDT, you'd have to come over here and say, okay, if that's the relationship, then DRDT is 1/4 DHDT. So we can throw in immensely 5/4 squared. So you're going to have to combine my terms. This shouldn't be totally impossible. That'd be 8 and 25. And I can pull out my DHDT, right? I can multiply that to be a 6 over pi. That would be 25 sixteenths. I would make that 2 over 2. So 50 sixteenths, 75 sixteenths. DHDT. I don't know if anything goes into that nicely. So 6 times 16 would be 96.
The answer is A.
Oh, the 3 goes in. Struggle. Should have reduced. Gnarly. Okay. So then 91. Naomi's question. Logistic. Okay. I've had a lot of logistic questions. That sounds silly. A lot of logistic growth questions over the last few days. From you guys. Logistic, what do we know? One way of doing y prime would be ky times l minus y. Oops. Another way of doing y prime is y times k.
I think it's A, Y,
Is that how you have it?
and then you did, yeah, I think so, and then you did 1 over.
Oh yeah, there's a weird way of doing it. Hold on.
Yeah.
I don't think that's helpful. I'll say that. And then we can do y of t is equal to minus lift. And there are other variations of that. Oh, that would be 1. That would be 1 minus y over l, and the l is out there, lky. Yeah. Yeah. There it is. Okay. Anyway, that's just like forever endeavor, let's say. Number of students in a school with heard a rumor is modeled by P. So now we're going to change all of this to be P's instead. So, okay, fine. That's going to be P. This is going to be P. That's going to be P. That's going to be P prime. Or P and P. So Y is just P now. At noon, 50 of the 500 have heard the rumor. Also at noon, P is increasing at a rate of 20 students per hour. Which of the following could be the logistical T hours? T hours from what? T hours. I would almost just make noon 0. I don't know if that's horrible to do. I don't want to make it 12 hours since 12 a.m. That's awkward. 12 hours from the beginning of the school day. Do you guys see anything to make time relative to anything? Per hour, T hours. If it doesn't work, it doesn't work. I'm going to make noon T equals 0. Okay. So if noon T equals 0, then I know of the 500 students. Oh, nasty. Why do you guys see 500s everywhere? If it's 500 total students, what's the maximum number of students that can possibly hear the rumor? You know, there's the one goody two shoes who's doing math the whole time in a classroom, right? And doesn't hear the rumor because they're just not listening. Okay, So it's going to get closer and closer and closer to that. I'm assuming that 20 is my initial condition, so P of 0, no, sorry, 50. 50 is my initial condition. And they're looking for the differential equation. So we can go ahead and plug in P prime is equal to Kp times L is 500 minus P. But then we need K. We could go ahead and say P is increasing at a rate of 20 students per hour, so we could set P prime equal to 20. That's what the rate would need to be. Also at noon. The problem is, though, at noon, I don't know what to set P equal to. If I knew what P was, then I could find K with this clue. So I need to go back to P and say, okay, well, who are you? Okay, well, if I plug in P at noon, I know, wait, they told me what P is at noon, don't they? Or didn't they? So P of 0 is 50, so if I'm trying to think about such that T equals 0, such that T equals 0, or whatever T is, they didn't, I don't even need to go to lice minus lift. They said, hey, at noon, when the rate is 20, when P prime is 20, P is equal to 50. It's like, oh, okay, I didn't even have to worry about noon, and that's why they didn't tell me what the T was at noon. Maybe it's, I don't know, 3 hours after the rumor started. It doesn't matter. The rate at noon coincides with the population of people who have heard the rumor at noon. So I can go ahead and just do 20 over 50 times 450. I'll be a lazy bum and I cut out some zeros because that makes life a little easier on me. Oh, it's a calculator problem. You guys just throw it in your calculator. But I was just going to do 5 times 45 is 225 and throw in a 0. I guess I could have done that to 25. Maybe that's easier. But that'd be 1 over. Is that it? Yeah. Okay, now I'm caught up. Wednesday or Saturday? Where are we going?
Can you do Saturday? 18?
FTC part 2, yeah. Because as soon as I see f being an integral and an f prime, I know I need to derive said integral, so I'm going to say derivative. Of any integral from a to u is f of u times u prime.
I'm confused where they got the pi in front of it, because the answer is D. So we'll just plug pi over 2 into that. I mean, square root.
Yeah. Because then you'll end up with cosine of root pi to the 6. Well, that's the same thing as root pi cubed squared, and the squared could cancel out the square root.
Yeah. Okay.
Yeah, is that good?
For 21.
Saturday?
Yeah, Saturday. I just didn't really know what method I should use.
My brain screams improper fraction.
Okay, so factor the top.
I wouldn't even factor. I would do, because I see messy.
Yeah.
I think division, polynomial division, will give me some nice and some remainder.
Okay, so do
Polynomial division. If it's not factored, great, that's all well and good, but long story short, that does not look an easy factor, even if it did go nicely. So I think for my brain, it would have been easier just to go this way the whole time. Be careful your subtraction minus and negative. first of all, C and D, heck no. It's a polynomial division problem with a remainder.
So it would be 6x plus 8, and then 9 over x minus 2.
And actually, just looking at the answers really quickly, those are the exact same. Anyway, plus C is the exact same. Isn't this a 9 over U? You don't even need to finish.
Okay. Yeah.
It's dangerous sometimes if they look similar enough, but oh, that was negative 9. See, I would have even got here wrong if I'd done.
Okay, and then 22. So for 22, I crossed out A and D, and then I knew it was between C and D.
C and B or C and D?
C and D.
Okay.
It's not A or D because like.
Oh yeah, 1 over n can never give convergence.
Yeah. And
1 over n squared can never give divergence. Good, P-series test, right?
Yeah, and so, but I put B and it's C. I thought since
I would do direct comparison. Except ln of n plus 1, that'd probably be hard for you to do direct comparison. How about limit comparison?
1 over n squared is smaller than 1 over n and 1 over n squared are both smaller than what they give us, right?
So if they're both smaller than what they give us, because you're thinking these are both stronger than ln, right? The individual guys? Good.
So smaller diverge, so it would be C. I think I just, because I literally wrote smaller and then smaller diverge and then I said,
you just did.
Yeah.
There you go. Okay. But you could have also done, like, in theory, you could have done limit comparison tests. You just would have had to do L'Hopital's. It would have taken longer. The only deal time.
Yeah, 29.
Of the same one?
Yeah.
Still on Saturday, guys, if you're using it. Number 29. What I see just quick, Naomi, is H is like my Y, right?
Mm-hmm.
And I see a derivative and I see originals. So in my head, I think, oh, I bet I'm going from a derivative backwards. And remember, from a derivative backwards, that's my integration. But think my FRQ is worth 4 points, 5 points, 8 points. It's a differential equation that I have to separate correctly. So then, AB, I've been trying. They've been resisting me for whatever reason. The first thing to do, get the dt to the other side. The same thing with you guys. Just split the differential up. And as soon as you multiply them up, this guy's grouped. So if I need to get the h's over here, the only legal way to do it is taking the whole thing over. And as soon as I have that, whether this is okay with your brain, or whether you'd rather see it like this, I need to do some u sub. That's just t plus c. And both one is t. If I have to do some u sub, this du would equal 2. So dh is du over 2. Let's go up here. So I'd have a 1/2 in front with a 1 over u. Du equals t plus c. Is that kind of making sense?
Yeah.
So the very first thing, get that guy up, because then that should parenthesis him, and I have to get h's all to one side. Then I can use my u sub. Go through your steps carefully, because pretty quickly, multiplying by 2. 2 times c, another arbitrary c, e to the, who is you? 2h plus 1 is equal to c, e. Well, they didn't even keep going, did they?
Mm-hmm.
Sorry, ln of 2h plus 1, they have ln of 2h plus 1 is 2t plus c. That was nice, and then they didn't even get h alone. You see it? Sorry, I just plugged in. Anything else on this is Saturday? Anything else on Saturdays and Sundays? Or do you want to go to Wednesday? Anything on Wednesdays?
Yeah, Wednesday.
Yeah. Do you find anything else? Or else you guys can start looking on Wednesday too.
Can you do 7 on Wednesday?
Yeah. Let me know.
It's a Oilers match.
7, right?
Yeah.
Anything else that you found? Yeah. Let me know if you find something. So now we're going to Wednesday. Hey, Oilers. We were working on this a little bit yesterday during fifth period. Not this problem. Oilers always has to start somewhere with an exact. And then it starts to branch off in an approximate way. So I see my initial and I'm like, okay, that must be my starting point. Then I see 2.4, but I have to get there in 2 steps. So if I'm getting to 2.4 in equal steps, that must have been 2.2. I use the previous y value, and I can't fill in this one until I find what that approximate is. And then it's like a tangent line where my local linear approximation is a y, which approximates, right, some sort of f value. y1 plus m times delta x. In Euler's method, that's an h. That's some sort of differential equation, maybe in terms of x, maybe in terms of y, who knows. And then there's that initial point, whatever it is that they give me. And then I'm approximating, I don't know, whoever. So in general, this is what we're doing. We're stealing the previous y, stealing the previous point for the differential equation, and then stealing the h. So I know that h right now is 0.2 just based on how far my x has progressed. My differential equation, I need a derivative back from this point. This point is 2. There's my derivative, so I'm doing negative 0.5.
Times 0.2.
Yeah. Which in my mind, it's just so much easier to do fractions. Because then I have negative 1/10, which would be 2.9. Does that make sense? Because this is a non-calculator, which is a beast, unless, I don't know, I just think better in fractions. But now I have to do the exact same thing. So steal that 2.9. Steal that h, it's the exact same. But now I have to go looking for the derivative, the slope at this dude, which was 2.2. So negative 0.3. Which isn't quite as much fun. But I would still think of 1/5, and then 30 divided by 5 is 6. So it'd be 2.9 minus 0.06, I think. So then 2.84.
Yeah.
But you could do like decimal multiplication.
12 on Saturday.
With 12 on Saturday. Implicit all the way. But this one, unlike related rates,
What are you doing? You're learning about
oh, French. Is it French? No.
Let's say start at 12.
Okay, derivative with respect to x, it's not like a t, so I don't need x prime, y prime, I just need, well, x prime is just going to be 1, so derivative of 3, derivative of tangent, but careful, times is dy dx. One of the most common mistakes, derivative of 4 is 0. So at which point I would subtract the 3, divide by a secant squared, but remember, secant is really 1 over cosine. So then dividing by secant is the same thing as multiplying. Nasty trig properties. getting dy dx. Not FRQ, it's multiple choice, right? Just
Yeah. On Wednesday.
R is the unbounded region between. Now, sad thing is this is a non-calculator. However, it says for x greater than or equal to 3. Don't think about what you don't know. Think about what you do. If x is greater than or equal to 3, and I plug in 3, 4, 5, 6 positive, if I plug in ln of 3, 4, 5, well, who cares? It's squared, but either way, positive squared is positive. I don't know what this dude looks like. I have no clue, but I do know whoever he is, he's up. And if I know he's up, well then if they're talking about it to me with area under, okay, well I know that area is going to start at 3 because that's the beginning point of my top minus bottom, which is just this dude minus 0. But hold on, what's my upper bound and how is it all counted words?
Oh, infinity.
It keeps going. You're in BC now. You're in BC now. Unbounded means it keeps on going and going and going. No boundary. So, I mean, they said start at 3. So I have a left boundary, but I don't have a right. So now we would just go ahead and do a limit as b goes to infinity of. Now, you said Liate. I know we're not doing integration by parts. But Liate is still good in that if you see an ln or an arc trig in an integral, start by thinking he's your u, because I don't know how to integrate ln unless he's a u. So if he's my u, du is 1 over x. Some of you might realize pretty quickly that we would be able to cancel out the x and we'd have 1 over u squared. Now be careful because this is an x bound. So I might go off to the side and come back to that and be like, okay, hold on. If I was doing an FRQ, I might just do this off to the side. And then I'd have u to the negative 2. And I would get negative 1 over u plus c. I would come back and I would say, okay, it's the limit as b goes to infinity of. And I would use this as my guide to negative 1 over ln of x. From, now I can throw in my b, my 3 to b. There we go. Negative 1 over ln of b as b goes to infinity, which means this dude just goes to 0, right? Minus negative 1 over let me know if I'm wrong.
Yeah. So you just, since the negative 1 over ln b is infinity, and then just ignore
The bottom wins.
0.
So this whole thing goes to 0 because this is going to infinity.
But if the top went to infinity, the answer would be infinity. Okay, is this over?
This class over?
Yeah.
Is this happening today?
Yeah.
Did the bell ring?
Yeah.
I swear the bell didn't ring. You guys know.